Aren't you impressed? Okay, thank you. All right, so here we are. So this afternoon, as I said, it's nice. It's the weekend. I hate having class on Friday afternoons. So let's try to be efficient and get through what we need to get done. So I want to talk a little bit about just a little bit of material that needs to be done to finish up chapter 6. And then we will go over your homeworks, and you can ask any questions about that. And then we'll save a little bit of time if you have any questions about homework number 2. Okay, so the last topic that we have to talk about in chapter 6 relates to growth accounting, right? So this is another empirical question. And so let me share with you, instead of using the iPad note-taking, I'm just going to share with you my notes here. Okay. So growth accounting. Growth accounting is really thinking about, can we break down growth into its different components, right? Can we be clear empirically where growth comes from exactly? Okay. And so this is how this is basically how you conduct growth accounting, or how economists conduct growth accounting. Let's begin with a Cobb-Douglas production function, the same Cobb-Douglas production function that we've used throughout this block. So you notice here that the numerator is just our usual Cobb-Douglas production function, and we're going to express it in per capita terms. So I'm going to divide by population. Okay, so output is equal to A, which is productivity, K, which is capital, and then LY, which is labor devoted to producing output. And then I'm going to divide this by L, which is the population. Okay, so notice here there's a difference between LY and L. L is the entire population, and LY is the percentage of the population that's devoted to producing output. Okay, or using a little bit of algebra, we can break this into the following form, which is that per capita output is equal to 3 things. Total factor productivity, productivity, our capital to population taken to the 1/3 power, or our labor force relative to the population taken to 2/3 power. Okay, so this is just a standard Cobb-Douglas production function written in per capita terms. Now, sorry, I'm just getting rid of this. Now what we want to do is we want to take this in terms of growth rates. So in other words, what we need to do is use those rules that we talked about on day 2, right? So if you remember on day 2, we said that output is equal to productivity, capital, and labor. But if we write it in growth rates, it's the growth rate of output is equal to the growth rate of productivity, the growth rate of labor, and the growth rate of capital. Well, we're going to do that same thing here, except now note that we subtract out the growth rate of labor, right? So what does the growth rate of output divided by, what is the growth rate of output divided by labor? It's the growth rate of output divided by minus the growth rate of labor, right? So this part, right, output divided by L in terms of growth rates is what's on the left-hand side of this next equation. Then we have A. This becomes the growth rate of A, which is the last part on this side. This becomes 1/3 the growth rate of capital minus the growth rate of the population. And then this part becomes, in growth rates, the growth rate of the labor force minus the growth rate of the population times 2/3. Would this be easier to see if I actually did this on the iPad and wrote this up, or do we kind of, are we able to see what's going on here just by looking at my typed notes? Okay, let me switch over and let me switch to my notes and let's try this again. Okay, I'm going to redo this here. Okay. So let me redo the math. Okay, so here's our Cobb-Douglas production function. Right? So I divide this by the total population to put this in per capita terms. Right? This can be simplified to this. Right? Because essentially, remember, I can rewrite this here like this, and then put L to the 1/3 with the K, then put L to the 2/3 with the LY, and then I get this, right? Now, let's write this in terms of growth rates. Remember, a relationship that is division relationship, how does it become in growth rates? It becomes subtraction. So this translates to that in terms of growth rates. This is using those 3 rules of growth rates that we worked out on day 2. What does A become? The growth rate of A. What does this become? The 1/3 goes out in front. And we get that. And then what does this last part become? This. Okay. So this is the growth rate of per capita output. This is the growth rate of productivity. This is getting very busy, but this is the growth rate of capital. And then this part is damn it. This part we can think of as the change in labor composition. It's really related very closely to what our labor force participation rate is. Right? Are more people working in the labor force from the population, or are less people working in the population? Okay. So to say this another way, the growth rate of per capita GDP is really based on 3 things: the growth rate of A, the growth rate of K, and then the change in labor force composition. Okay. Now, this is where the work comes in, or this is where the insight comes in. Because if you think about this, we can get data on all of these things but one. We have data on per capita GDP. We have data on capital. We have data on labor force participation and labor force composition. So if we have data on all of these things, do we have data on A? No, but we can calculate A, or let me say you can calculate the growth rate of A as a residual, meaning what's left over, right? So the growth rate of A here is just equal to the growth rate of output minus the growth rate of labor minus growth rate of capital minus the growth rate of labor minus 2/3 the growth rate of labor force participation versus the growth rate of labor, right? We calculate it as a residual. We have data on these things. Right? We have data on those three things, and so we can use this to calculate what the growth rate of productivity is. So productivity is not directly observable, but we can estimate it as a residual, right? In other words, it's the part of output that cannot be explained as inputs. And that's what we call, this measure of output is called total factor productivity. Total factor productivity is a measure of A calculated as a residual, right? In other words, another way of saying this is it's the growth of output that cannot be explained by the growth of inputs, meaning capital and labor. It's growth in output that cannot be explained by growth in inputs. It's a residual, right? It's what's left over after we subtract out the growth in inputs that we can directly measure. So this is one way that we can measure productivity, right? This is one way that we can directly measure productivity. And so that's what growth accounting is using this approach to try to measure productivity and to measure how important productivity is to changes in output and changes in growth, okay? So let me show you some data in which we actually do this, right? So this is table 6.2 from your book, and this is looking at growth accounting for the United States, okay? Let's look at this first column here for the entire period of 1948 to 2017. What was the growth in output per hour, right? Here, instead of using it as per person, they've actually done it per hour, but it's a very similar idea. The growth in output per hour is 2.3%. What was the growth rate in capital per hour? 0.9%. What was the change in labor composition? 0.2%. And so as a residual, what was the contribution of A, total factor productivity? It was the rest. So basically, if you take 2.3% minus 0.9%, minus 0.2%, you get 1.2%. So what does that mean? Well, if you think about this, this is actually a really interesting result. Notice that of that growth in output, half of it was due to productivity. Half of it was due to productivity. The rest of it was due to increases in capital and labor, primarily capital, right? You'll see that labor composition really doesn't change very much over this entire period, and that makes sense, right? The US labor force evolves very, very slowly. So it's never going to change. It's never going to be a particularly big factor in changing growth one way or another, at least over longer periods of time. And so what we see here is that productivity, total factor productivity, accounts for about 50% of output growth. Capital, about 40%, and labor, only about 10%. So once again, as we found throughout the last couple of days, productivity, 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 right? Productivity is the most important factor in determining differences in income across countries and explaining growth over time, right? So when we talk about growth over time in the US, we see that half of it is due to productivity, right? And only about half of it is due to inputs. Now that's interesting, right? That's interesting. However, also very interesting to us is if you look at these different time periods, we'll see that the behavior of productivity has differed quite a bit over time. For instance, the period 1948 to 1973, notice how much faster growth was in this period. This was the post-war era, right? So in the post-war era, notice that output per hour went up from 2.3% to 3.3%. Why did it go up? Almost entirely because of higher productivity. Throughout this era, you'll see in the general, very little changes in capital and labor, but a lot of variability in productivity. So this period of 1948 to 1973 was a high period of productivity growth, and we had high output growth. How about the period between 1973 and 1995? Well, notice that this was a period of relatively low output growth. Why? Because of relatively low productivity growth. So once again, productivity is driving changes in economic growth over time, right? It's playing a big role. When productivity is high, growth is high. When productivity is low, growth is low. That tends to be the biggest reason. This period, 95 to 2003, once again, we see a repeat of the post-war era. Output growth was high, and so was total factor productivity. Here, capital was also a little bit higher. And then finally, you see basically the 2000s. And we've talked many times about why people have been pessimistic about the US economy. I mean, this column right here, looking at the performance of the US economy, tells you a lot. That output per hour the growth in output per hour has been lower since the 2000s, or since 2003. Why? In part because capital growth has been lower, but also surprisingly because total factor productivity has been lower. So in other words, these changes in productivity are really driving a lot of our changes in output. This points to the fact that total factor productivity growth is a huge factor in determining how well our economy does in general. I mean, we can talk about the labor market. We will talk about this on Monday. We can talk about capital. We talked about that a lot in the Solow model, but productivity is really the big factor. And, if you look at this in a different way, if you look at this graph, you can see how much productivity has really kind of fluctuated over time, right? That there's a lot of variability in productivity, and this leads to a lot of variability in economic growth. So all of this points to the fact that productivity is really, really important. The data tells us that productivity is really, really important. Why is that interesting to us? Well, it's obvious, it's interesting to us, but it's also frustrating to us. And the reason why it's frustrating to us is because we don't really understand why productivity has gone up during certain periods or why it's gone down, right? economists don't understand why productivity growth has been lower the last 20 years. We really don't. Just like we don't really have a completely persuasive story about why productivity growth was high in the post-war era, or why it was low between 1975 and 1995, or why it was high between 1995 and 2005, right? We have not really been able to establish, I think, stories for productivity that all economists can completely agree with. We can rule some things out. One thing is, we know that this isn't necessarily because of government policy, right? Some people have said, well, maybe it's because government policy, maybe the government regulates too much or taxes too much. The thing is, we've observed very similar behavior across other countries with different governments and different government policies. So this seems to suggest that it's not really, we can't rule government policy out, but it's hard to see government policy as the big driving factor here. So what are some of the other reasons why productivity has gone up, and particularly why has productivity been lower since the 2000s? And I'll just say that there's really, I would say there's kind of three arguments that seem most persuasive to me. I don't think any of these are completely lock explanations, but I do think that there's at least three explanations that I hear economists talk about that seem persuasive to me. The first one is that there's demographics changes in the US, right? We have an aging population, we have lower birth rates, we've seen that educational attainment growth has actually slowed in the US, right? There's a dramatic slowing in the number of people who are going to college, for instance, and finishing college. So these things might be showing up in productivity. They're probably going to show up very slowly, but they are going to show up nonetheless. And so, many economists have argued that the reason productivity is slowing down is because it's really a function that we have a much different population than we have had in the past. Some people have pointed to the move from manufacturing to a service-based economy, making the argument that we now have a much more labor-intensive economy. But the problem with labor-intensive economies is it's harder to increase the productivity of labor because labor involves humans, right? And humans have natural limits to their productivity, right? So, just to give you an example of this, you can keep on making faster and faster laptop computers, but the fact of the matter is, no matter how fast you get your laptop computer, what's the fundamental constraint on how fast you work? It's you. It's not the computer, it's you, right? So I can have a very fast computer, but usually how fast my work is going to get done is going to be limited by how fast I think, how fast I type, right? And how hard I work. Most of the limits to production are on the human side. They're not on the capital side. So as we move to a more labor-intensive economy, we're really, in many ways, relying more and more on humans, strangely enough. Could this change with artificial intelligence and robotics? Maybe, right? Maybe. But, right now, it's quite possible that this move to a more service-based economy is actually reducing productivity in many ways, right? And then finally, I think many economists have pointed to growing economic inequality as a potential reason for lower productivity. Because what we've seen is that as economic inequality has gone up, we're seeing lower educational attainment across the board, right? Particularly in poor and middle-class households. So the more that income is held by the rich and less is held by the middle class and the poor, that means it's harder for them to invest in many of the things that they need to invest in to keep the aggregate economy growing fast. And so, many economists have been arguing that the fact that educational attainment is slowing down is directly related to inequality. Also, the fact that intergenerational mobility has fallen. Intergenerational mobility refers to the fact of how correlated is a kid's income relative to their parents' income. Here's an amazing fact, right? Today in the United States, the correlation between a kid's income and their parents' income is stronger than the correlation between a child's height and their parents' height. Okay, let me say that again. The relationship between a kid's income and their parents' income is stronger than the relationship is between a kid's height and the parents' height. There is not a lot of intergenerational mobility in the United States, right? And we'll actually look at some data on this a little bit later in class. Not a lot of intergenerational mobility. And so if poor people are kind of trapped to being poor, that is a huge disincentive to invest in the kind of things that lead to increases in aggregate productivity. So, we see some of the population doing that, the rich, the privileged parts of the population, but if more and more of our population feels like they're kind of trapped in poverty, that means that, many of those people are essentially dropping out. They're not joining the ideas economy. They're not creating the kind of productivity advances that we need to keep the aggregate economy growing at the rate that we would like it to. And so this is really a huge research question in economics. How do we better understand movements in productivity, right? How do we understand that? Why is productivity gone down in the 2020s, right? This is a fundamentally important question that I think economists are really in many ways struggling with right now, right? I mean, some of the best minds in the profession are definitely trying to think about how do we understand these movements in productivity? And what can we do about it, right? What can we do to get productivity higher? Because the fact that productivity and growth has been low has definitely played a huge role, not just in how big our pocketbooks are, but I think it's played a lot of the role in how dysfunctional our politics has gotten, how at times dysfunctional our society has gotten, right? As inequality has led to crime and privilege and discouragement. I mean, all of these kind of social and economic ills that we have, a lot of it can be traced right back to productivity. And so quite honestly, economists don't understand productivity as much as we need to, right? And so this is a huge part of a future research agenda in macroeconomics is how do we understand this better? Okay, so that finishes up chapter 6. And you'll notice that one of the questions on your homework number 2 is actually asking you to do a little bit of, do this growth accounting exercise. Do it for two city-states, right? Do it for Singapore and Hong Kong and compare and contrast the two, right? And so you can, I think that's question number 8 on your homework. I can't remember exactly, but you'll have a little bit of a chance to do some growth accounting of your own for Singapore and Hong Kong in your homework. Okay, do you want to go over your homework number 1 very quickly? All right, let's go over homework number 1 relatively quickly. I have made up a little key here. And so let me just kind of walk through this pretty fast. And then please jump in and slow me down if there's something that I'm skimming over or if you're confused about something on your homework. So for the most part in question number 1, we didn't have any problems. I think most of you were able to get the ratios of per capita income in the US or per capita income in these countries relative to the US, right? So income in these countries should be in the numerator, income in the US should be in the denominator, right? Most of you had no problem calculating the growth rate, which is larger as a share of GDP. Investment or government purchases. In all of these countries, investment was larger than government purchases. Question number 2, obviously this is different for all of you because most of you picked different countries. Yeah, I don't think there were any big problems here. I think almost everybody got question number 2 right who did it. Question number 3. So this is using the chain weighted GDP. I'm not going to work through all this because it's very tedious and time consuming to do this as a group. If you missed this, I actually pasted this answer, or I meant to paste this answer into my comments. And so what I would encourage you to do is to go back and work through this on your own and see where your work differed from my work. okay? But I should have pasted this answer into your homework if you had any problems. I think for the most part, most of you were able to figure this out. Of course, you know, the key to chain weighting is you have to do this twice, right? You first have to calculate the inflation rate between 2013 and 2014 using 2013 as a base year. Then you have to do the same thing using 2014 as the base year, right? So anyway, I'm just going to kind of let you look through that, through my answer on your own time. How would your answers be different? Well, you know, of course, the key thing about chain weighting is when you use two different base years, what you're doing is making sure that, you know, the fact is that if you just use one base year, certain goods can be weighted more heavily in that year than in other goods. So using a base year tends to average out the differences that occur in inflation because some goods get weighted more heavily than other goods in different years. Okay, calculating trend and detrended, you know, once again, I don't think there were any big problems here. There were one or two little problems where people, I don't know if you made math errors or you made small mistakes. Once again, I tried to post the right answer into your comments. So look at the comments of your in your homework and see if you can, hopefully you're able to kind of deconstruct my cliff notes here of what went on. Question number 5. Once again, I think most of us did pretty well on this question. This is the question where you're asked to calculate GDP and then detrend it using a linear trend first and an exponential trend, okay? And so when you did that, right, here's actually one graph. You can see what the linear trend looks like. It's obviously the linear dotted line. And what does the exponential trend look like? It looks like this exponent, it's the curved dotted line, right? And so how do you get detrended GDP? You take actual GDP, which is this blue line, the solid blue line, minus trend, which is the dotted line, right? And you have to do that for trend when it's exponential, and you have to do that for trend when it's linear. And so what do you get here is you get this graph, right? Where orange is detrended and gray is, orange is detrended linear and gray is detrended exponential, all right? And Jonah, let me give you a shout out. I think I actually stole your graph here. I actually liked how you did this and put them on the same graph. When I did it, I put it on separate graphs. I was like, oh, that's a good idea. Why didn't I think about that? So this is actually Jonah's graph of detrended linear and detrended exponential. So which of these fits the data better? Well, I mean, it's a little hard to tell empirically, granted, particularly because there's a lot of observations kind of jammed in here. First off, intuition tells us that exponential makes more sense, right? And so I think, you know, probably we should go with exponential trends simply because our intuition tells us that GDP growth should be exponential. But I think there's also another reason, if you look at this, why exponential is better. Notice how when you look at trend, detrended GDP, or when you look at linear detrended GDP, notice how there's a lot of positive errors, then there's a lot of negative errors, then there's a lot of positive errors, right? Those errors are not random. They're not even close to being random, right? If we are really detrending, errors should be kind of random. There should be positive and negative. They shouldn't all be positive or all be negative. And part of that is because you can see from this graph, what happens if you fit a straight line to a curved variable? You fit the straight line, you're going to have positive errors, negative errors, positive errors, right? And so a detrended exponentially, once again, you know, there's a lot of correlation between your errors, but it looks a little bit more random, right? It's not so much the truth, there's so much the case that you get a lot of positive errors, then a lot of negative errors, then a lot of positive errors. So anyway, so that's question number 5. Does anybody have any questions about that? As I said, I think most of us were able to get detrended GDP. Some of us didn't do it both for a linear detrend and exponential detrend. I think many of you just did one and you didn't do the other. And I wanted you to do both to compare. And then sometimes I think there were small problems in terms of how you talked about it, or, you know, you kind of summarized your results. Question number 6. So for many of you, I just gave you a pass because you started talking about unemployment. And, you know, as I said, I had a typo here. I meant to have real investment, right? So unless you kind of, if you had an answer to this that dealt with real investment and you did it wrong, I took points off. But if you had an answer that was dealing with unemployment, I basically kind of let you go, right? So how did I want you to answer this question if I hadn't had the typo? Well, really what I want you to take is take real investment and detrend it, right? Real investment should follow exponential growth, just like GDP. And so detrend it. And so if you detrend it, you get detrended exponential growth here, the orange line, right? And then the gray line is detrended GDP. No, I'm sorry, I got these backwards. The orange line is detrended GDP and the gray line is detrended investment. And so what's the relationship? What's the relationship between these? It's pretty clearly pro-cyclical. They're positively related. What you should do is calculate the correlation coefficient. I didn't write this down. But if you actually calculate the correlation coefficient between these two, the correlation coefficient is 0.37, which is positive, meaning that there's a positive relationship between detrended investment and detrended GDP. And so we would call that pro-cyclical, right? Once again, pro-cyclical is when you have a positive correlation between the detrended variable and detrended GDP. And so private investment is pretty strongly pro-cyclical, right? Pretty strongly pro-cyclical. Okay, finally, question number 7. So we had some problems with this one, and it's because many of you did not use the implied constant average growth rate formula that we developed in class. So remember what the growth rate formula is. Actually, let me pull up the growth rate formula. Hold on one moment. Ah, damn it. Wrong one. Trying to remember when we talked. Was it in chapter 2? Shit. I should remember. Did we talk about that in chapter 2 or chapter 1?
For me, it says it's chapter 4.
Oh, chapter 3. We talked about it in chapter 3. That's right.
It was afternoon of Tuesday class. If you're looking for the video.
I'm not looking for the video. I'm trying to find my notes on it so I can show you the applied growth rate formula. Well, I'll just type it up here. So you remember what the formula was. We showed that the growth rate was yt plus n, output in period t plus n divided by output in period 0. All to the 1 divided by n power minus 1. Okay, you remember? Wait, I'm not showing this to you. Apologize. Get this right. Okay, this was our growth rate formula. Right, that output, you take output in period t plus n, and so in other words, output at the end of the period divided by output at the beginning of the period, all to the 1 over n power minus 1, right? That's how you calculate the implied constant annual growth rate. What many of you did is you just took, for instance, you took the output in 1980 for this first part, and then you took output, you subtracted out output in 1990, and then you just divided by 10, right? But you can't do that because what you're doing there is you're calculating an average growth rate as if there's no compounding, right? So just taking, the difference between the two and dividing by 10 is not including compounding. The fact that growth leads to growth, right? So you need to calculate a compounded annual growth rate, not just an average, right? And so that's what we call the implied average annual growth rate. And so you have to use this formula to do that. So I've given you the answer here. I think I copied and pasted this into most of your homeworks, but here's the actual answer that you have to do, where notice here, you take the output at the end of the period, you divide by output at the beginning of the period, and then you take it all to 1 over n power, and then you subtract out 1. That gives you the growth rate. Okay. Is that clear to everybody? All right, so you just can't divide by 10 and call that a growth rate because it's not incorporating compounding.
I have a question about that.
Yeah.
So I used that formula, but my inputs for the beginning y and end y were different. Where'd you get 31.05 and 42.09?
Just from the Excel spreadsheet. I don't. What number did you get? By the way, who's talking?
I got
you.
Carson.
Okay. Hey, Carson. So you know where you got that?
Yeah, went to the data spreadsheet, and my per capita GDP for 1990 was 11,250, like 11,250.
I think he did it not relative to the U.S.
Oh, okay.
Yeah. So let me look at it, Carson. If you just picked the wrong numbers, I'll go back and look at it. If you just pick the wrong numbers and you use a different version of GDP, then I don't know how much I took off, but I'm willing to give you some partial credit back for that. So let me, at the end of class, I'll go back and look at it and reevaluate, okay? Okay, and then finally here for question number 8, this time we wanted to take not per capita GDP, but just take real GDP and put it on a ratio scale, and then calculate the implied annual growth rate of GDP over this entire period, and using that implied annual growth rate formula. And so when you do real GDP here on a ratio scale, you could use whatever ratio you wanted, and whatever you pick as your initial year, or your initial value, it should basically double on this axis, right? And so what you see is that this becomes much more linear, not surprising. Using our implied annual growth rate, GDP at the end of the period was 18,583. At the beginning, it was 2,033. Take this to the 1 divided by 73 power, because there's 73 periods. You subtract 1. You should have got something close to 3.14%, right? Give or take a little bit depending upon rounding, etc. Okay, so that's the implied annual growth rate. All right, so in general, honestly, I didn't see any big problems with your homeworks. There were some little problems here and there. Probably the biggest problem is I think a lot of you were confused about how to use the implied annual growth rate formula. I think many of you just kind of took the average, right? Just divided by 10, and you can't do that, right? But, as I said, in general, here and there, little problems, but it appears that for the most part, you did pretty well on this homework. So as I said, these questions, many of these questions are examples of the kind of questions that you're going to see on your exam on Wednesday. Now, on your exam on Wednesday, I obviously am not going to give you a big data set and ask you to do some analysis in Excel, right? So I'm not going to ask you to, I'm not going to give you a macro data set and say, hey, detrend it and show me what it looks like. But I could ask you, what steps would you do if I asked you to do that, right? In other words, I could very well ask you to explain how you would detrend a variable like real investment or detrend a variable like stock prices or something like that, right? So I'm not going to ask you to do that kind of stuff on the exam, but I could definitely ask you to explain it. And then really many of the other questions on this homework are actually questions that are right off previous exams, right? I could ask you to use the implied constant growth rate formula, certainly ask you to calculate chain weighted GDP, you know, all these kind of questions are definitely questions that would be fair game for the exam. So anyway, we will talk about the exam on Monday or Tuesday. Actually, one of the things I want to do this weekend is, just to be frank with you, I haven't really thought about how we're going to handle the exam, right? Given that we're all taking this online, I haven't really come to a final conclusion about how I want to handle this, if we're going to make this open book, if we're not going to make this open book. There almost certainly will be a time constraint associated with this. So I'm just going to spend a little bit of time this weekend coming up with a plan that I think works for the exam, and then we can talk in more detail on Monday about the exam, right? So that you have a little bit of time to kind of get prepared. So in the meantime, definitely this weekend, make sure you spend some time on homework number 2, right? And get that done. And then prepare yourself for, you know, catch up on anything that you kind of fell behind on this week, whether it's your readings from the book, whether there's some maybe notes that you have to go back and review, or some things that maybe you kind of missed the first time. You can go back and watch those lectures. Yeah, so this is a good weekend to kind of get caught up and get ready with your eye on that first exam, which is on Wednesday. So does anybody have any questions about where we're going next week, either about homework number 2 or about the exam or anything like that? All right, well, if not, have a good weekend. Yeah, sure.
So when you say time frame, you mean like it's going to be like our normal test time, or since we're all like some of us are in different time zones and such, is it going to be?
No, we're going to. I would like to. We're going to take it all at the same time. So when I say time frame, I mean I really have to sit down and think about how much time I'm going to give you for the exam. So I have to spend a little bit of time thinking about how long it is, how much time I'm going to give you. But it is going to be a timed exam, and we are going to start all at the same time, presumably at 9 o'clock, which is when we usually start class. All right, but I definitely want to think through that a little bit. So if you, and I'm really talking to students who are not in the United States, if you think you're going to have a problem with taking the exam at 9 a.m. Central Standard Time, reach out to me and share with me your concerns, and I will take those into consideration when I figure out how we're going to work these logistics. But right now, my intent is for us all to take the exam at 9 o'clock. And then as I said, this weekend, I'm going to try to spend a little bit of time thinking about how I kind of want to work this whole thing. Okay? Okay. All right. Well, have a good weekend. See ya.
Hey, Todd.
Yeah.
I had a question about the implied growth from the first homework.
Yes.
So I also made the same, like I didn't choose the right number, the relative to the US. But when trying to plug in the numbers, I got confused on what number was YT plus N and what number would be YT. So is YT just like Y0, like the beginning?
Exactly.
Okay, and then YT plus N would be like the ending one?
Yes. Yes.
Okay.
So
I got confused on that.
yeah. So hold on here for a minute. I'm going to pull up your homework and just look at it, what you did.
I don't think I wrote down the steps. I just put down the answers.
Right.
So I do have like my homework pulled up like in my journal. It's a little messy, but I can send you a picture if you want that.
Okay, but I can tell that you actually, I know that you didn't just calculate an average. So I tell you what, Rose, I'll give you half a point back on that.
Okay.
just be more careful about about that in the
Yeah.
future. Okay. But yeah, I see now. Yeah, I guess you did it wrong, but you did it closer to doing it right, if that makes any sense.
Yeah, it does. Thank you.
Okay. Okay, sounds good. And Carson,
Have a nice weekend.
yeah, you too, Rose. Carson, let me pull up your homework and just take a look at it.
I also, after this number 7 problem, I had some questions on number 2, the first chapter of that homework.
Okay. So yeah, I guess I'll give you half a point back as well, because I see that yeah, I guess you picked, I don't know what numbers you picked because you really didn't give me any, you didn't write it down.
Yeah.
So once again, it's kind of hard for me to know what you did if you don't give me a little bit more information, but you didn't calculate just the simple average. So I'll give you a point back, or I'm sorry, give you half a point back for that. Okay.
Yeah, so did it say that it needed to be relative to the US in that problem, or because I just took the regular GDP?
Well, it's not actually, if you look at it's not relative to the US. I think it is, it's per capita GDP in Mexico in US dollars.
So, okay. So I had to do like the exchange rate, or?
No, I think you just
Or-
had to use the data from, what was it, like column 3, if I remember.
Oh, okay.
I don't have it pulled up.
Yeah, I just did.
Yeah. But listen, it's not a big, honestly, it's not a big deal. And on your exam on Wednesday, you're not going to be pulling up data. It's probably be a little bit easier to figure out what data I'm referring to. So yeah, it's not a big deal. So you said you also had a question about which one?
Homework number 2, that just like pretty much all 3 of those first chapter 1 questions, or the chapter 4 questions, I was real confused about. Well, let me pull it up. Goodness. Okay.
Okay.
So for number 1A,
Mhm.
I just did the wage equals 1/2 times y over L. And then R equals 1/2 times y over K. Is that right?
Yes, but you can also plug in for y there and simplify it down even more.
Okay, I got you.
Okay. So I would encourage you to do that. I mean, I don't think I would count it wrong, but I think I would ask you to simplify it down a little bit more.
Okay. And then for B, I have, so I got really confused about how to calculate the diminishing marginal returns, because all I can see how to do right now is like see if it's constant returns to scale, or I can only see the returns to scale right now, because that's when you look at the production function, right?
So constant
And
return to scale refers to the entire production function. If I
Yeah.
double both inputs, what happens to output? Diminishing margin returns refers to only increasing one input. And it says the marginal product of that input should rise the marginal product of that input should fall as the quantity of that input rises. So how I would recommend you do this one is look at your formula for the marginal product. And can you show that the marginal product goes down? Like, for instance, the marginal product of capital goes down as the amount of capital goes up. That's diminishing marginal returns.
So the marginal product of capital would be 1/2 times y over R.
Y over K.
Y over K. Okay.
Yeah.
Oh yeah. Yep.
Right. Then you could simplify in for Y and simplify that down, but show that relationship, that the marginal product goes down when capital goes up.
Okay. Okay. Yeah, I got confused. I was trying to do the returns to scale instead of marginal returns.
Yes,
Um,
those are two different things. Definitely two different things.
Yep. And then, yeah, C and D, I just didn't even know how to get started. So like it says derive equilibrium output, but there's no like actual numbers to use. So
So you got to do this algebraically. I mean, we did this in class, right? We did this in class. So figure out what equilibrium output is and what per capita output is. So we did this in class. There's not a number to derive. There's just an algebraic relationship.
So you would use this original production function and then
Yeah.
And then, well, wouldn't that be equilibrium output then, or would it be? Yeah, I just don't even know, because wouldn't the y in this be the equilibrium output in that original production function?
Mm-hmm. You're way overthinking it. It's pretty straightforward, right? It's pretty straightforward. And it's not even so much as derive as just tell me what equilibrium output is and what equilibrium per capita output is.
Well, yeah, but so K and L are fixed in this, right? So it would just be y then for that.
Well, what's the
original
formula
production?
for y? And then what's the formula for per capita output? So give me the formula for output and the formula for per capita output.
Y is productivity times capital and labor with the exponents on top, and per capita is y divided by L by
Right.
labor.
And then simplify that down.
So for the per capita output, would I input the original production function for y, or?
Yep. And then divide by L and then simplify.
Okay.
Right. We did this in class. So why
Okay.
don't you go back and look at your notes of what we did in class, but we really
Okay.
do this in class.
All right. All right, I'll go look back for number C, and then if D, I can probably figure out D once I figure that out.
D is a more intuitive question. It asks me to provide a
Yeah.
graph and kind of do some analysis.
And then yeah, so A, I said wages would have increased and rental rate would have stayed the same just based on the wage equals 1/2 over y over L, or times y over L. Because if you change the labor, if you decrease labor, then that would it'd be 2/3 times a larger number, so it would increase. So that's how I got that. But then for B, how do because there's no numbers to decrease the 3%, to decrease by 3%. So I don't know how to.
So you can think of a ratio. If the labor force in your equations, if labor force goes down by 3%, what happens to the wage? It's going to change by 1%. What is that percent? You don't need a specific number. You can think of it as a ratio, right? So if labor force goes down by 3%, what happens to the wage? By what percent will the wage change? That you can figure out.
All right.
So you're not going to get a number here. You're really going to get a percent change in the wage.
I guess I was trying to figure it out.
Yeah, spend a little bit of time thinking about it.
All right, I'll spend some more time. I just got stuck last night. I spent a couple, 2 hours on these 3 problems, and I just couldn't figure it out.
Did you have a question about the third problem from chapter?
Yeah, so I did number A. I got all those 2 columns worth of numbers for all those countries. But then B, it asked for Oh, my textbook's in my bag right now, but hold on. So for 5B, it asks for compute per capita GDP for each country relative to the US. Assume no differences in A. So it'd just be that the production function equals A times K now with like K 1/3 and L is 2/3. So you could like take A outright since there's no differences in A.
No, notice here that it's lowercase y, so it's per capita output. So you have to do this in per capita terms. You have to use the per capita production function that we derived in class. That formula. So don't use the aggregate production function. Use the per capita production function.
Okay. And yeah, I couldn't figure it out. I was stuck on this one for like 45 minutes. I just was just looking at the numbers and I just could not.
Why don't you working on some more? Are you working with anybody on these?
Not really. I mean, I'm kind of at and just in my little bubble.
Yeah. So do you know anybody else in class? That you
I know like one guy.
Mm-hmm.
All right.
I mean, first off, yeah, I do think it helps to kind of talk through things with people, right? Now, I mean, part of this is you have to do kind of grind this through yourself and figure out some stuff for yourself, right? But part of it is talking with other people can help ideas leak and match, as we talked about, right? So some of this is it helps to kind of talk through things with people. So you have my emails that I sent you. By the way, I'm sorry, let me just